Good day, viewers. In this lecture, we'll be looking at second order differential equation. If you are new to this channel, consider subscribing, turn on the notification bell so that you can be notified when new video drops. Alright, now when we talk about the second order differential equation, this is the equation we're referring to: a naught d2y. So when we talk about the second order differential equation, we are referring to equation of the form a2 d2y dx squared plus a1x dy dx plus a naught of x equals f of s. Call this equation 1. So this is the equation we refer to as the second order differential equation. Why do we call it the second order differential equation? Because the order is just the highest derivative present. So the highest derivative present in this equation is 2, so it is called the second order. Okay, now if your f of x is equal to 0, equation 1 is called homogeneous equation. If f of s is not equals to 0, equation 1 is called non-homogeneous. Equation. So we'll be looking at the homogeneous equation in this lecture. So in the next couple of lectures, we'll be studying the non-homogeneous equation and how to solve it. But in this lecture, we'll be considering the homogeneous equation. So look at the homogeneous equation. We have a2 of x d2y dx squared plus, we are restricting ourselves to the case where this is they are just constants. So in the general formula, there could be a function of x, like you could have s squared, you can have like s squared here, but what we are doing now is the one that we will just have like a constant alone. So we can just say all of them are constants. So this is what we are restricting ourselves to, equals to 0. So you can just say where a2, a1 and a0 are constants. Okay, so now let's solve. How do we solve this kind of problem? Stay with me. Now you say let y be equals to exponential ms. So let y be equals to this, and if this y equals to this is a solution of this equation, if I call this equation 1.1 now, for example, so let y be equals to this. Okay, let me say suppose let's say suppose y equals to this is a solution of 1.1. Suppose this is a solution of 1.1, then if it is a solution, then if we substitute it into this equation, we should get 0. So we have y, so we need our dy dx and also d2y ds. So that would be dy dx now. So if you look for dy dx, you get m exponential mx, and if you look for d2y ds squared, you should have m squared exponential ms. So let's substitute this into the equation. We get a2 m squared exponential mx plus a1 m exponential mx plus a naught, which is a naught then exponential ms, equals to 0. Now something is common, exponential ms. If you bring it out, you have a2 m squared plus a1m plus a naught equals to 0. So exponential functions are not 0. They can't give you 0 no matter what. For all s, there is no way you can have 0. No matter what s is, this thing is always greater than, is always non-zero. Okay, so, and it's always a positive function. You can't have so let me just say it is always greater than 0. No matter whether s is negative or positive, you always get something greater than 0. Okay, so the only thing that can make this expression 0 is if our a2m squared plus a1m plus a naught is equal to 0. So if only this is equal to 0, so I can call this 1.2. So 1.2 now is called auxiliary equation. So when you have an ODE of second order differential equation, to solve it you need to get auxiliary equation. You can see it. Your d2 over dx squared is just like we are replacing it by m squared. Your dy dx is by, we are replacing it by m, and then y becomes your a naught. So this is what we call the auxiliary. This is what we call the auxiliary equation. Okay, we call it the auxiliary equation. So because we are solving a second order differential equation, we are meant to get two solutions. So the one we did now is just one solution. We can call it y1. So there is still another solution, which is y2. So let's say suppose y2 equals exponential, I don't want to write what it is. Let's just say y2 equals exponential, let's use another constant, kx is another solution of equation 1, equation 1.1, equation 1.1, not 1, equation 1.1. Then y equals ay1 plus by2 is called the general solution. So this is very, very important. So you are solving a second order differential equation, you are meant to get two solutions, so y1 and y2. So this is also called a linear combination. So this is their linear combination, is also another solution, and that solution is called the general solution. So when they give you a differential equation, maybe second order, they will ask you to get the general solution. So this is how your general solution should be. You should have two constants and then y1 and y2 that are independent. Okay, so the next thing now is to study this auxiliary equation. Let's focus on yours, because that is what we are going to solve, and it's more like a quadratic equation. So because it is more like a quadratic equation, then we have different kind of roots. So first, if we have real and distinct roots, what does that mean? That is, if we solve it and then we have m to be equals to, we solve the equation and then we have two roots, let's say m1 and also m2. So if these two roots are different, okay, so m1 and m2, they are roots. So if m1 is different from m2, we call that distinct roots, and it is real, it is not a complex number. So if you have distinct roots like this, what will be your general solution? So I'm just talking about the general solution now. It will be a exponential m1x plus b exponential m2x. So this one is your y1, while this other one is your y2. So you see, this is called your general solution. Okay, that's your general solution. Just have to remember it whenever you are dealing with, whenever you solve the quadratic equation and then you get a real and distinct root. Next on the line is you have real and equal roots. That is, if m1 is equals to m2. So if they are equal, you can pick one, just say m. You don't have to say m1 and m2 again. So if you still use this previous formula, look at what will happen. You will get a exponential mx plus b exponential ms. If you look at it, exponential ms is common, that will be a plus b, right? And this one is a constant. If you add the constant together, you get another constant. Okay, d is equal to a plus b, so it gives you another constant. So at the end of the day, what we have doesn't follow the general formula structure that says we must have two constants. So this is wrong. Okay, this is wrong. It's not correct. So this is wrong. So what is this supposed to be? We must have two constants that are distinct. So because of that, we now write a plus bs into exponential ms. So this is the general solution. Okay, this is the general solution. If you even open this bracket, you will see what your a and b are, your x and your y1 and y2. In this case, y1 is exponential ms, while y2 is s exponential ms. So they are different, they are not the same. So this is called your general solution when you have equal roots. Okay, so the third one, the third formula is the complex root. Okay, so you have complex roots. So m is equal to, m is equal to m is equal to a plus minus, alpha plus minus beta I. So this is a complex root. Okay, so in this case, our m1 is equals to a plus beta I, and then our m2 is equals to a minus beta I. So this is more like a distinct root. So if you put this into the distinct root formula, you get a exponential alpha plus beta I. This is alpha. Then plus b exponential alpha minus, sorry, there is an s here, so you are meant to put an s, okay, because it's mx. So in this case, if you open that bracket, you have ax plus beta si. The other one will be alpha x minus beta xi. Okay, so if you use law of indices and split that, you get this. Okay, now what is common? This is what is, you have exponential alpha s common on both sides. So if you bring it out, you have a exponential beta xi plus b exponential minus beta xi. Okay, now there is something you need to know in mathematics. There is exponential minus I. This exponential minus I has a formula. It is cos x plus I sin x. Okay, so if I now have exponential beta x in bracket then I, what it means is that in place of s, just put beta x. So you get cos beta x plus I sin what? Beta x. So there are two. We also have exponential minus beta x then I. So this one too will follow the same function. We get cos minus beta x, then plus I sin minus beta x. Another thing you need to know is that you see the cos function is an even function. Because it's an even function, let's say even function, the cos will be this cos minus x will still be cos x. While the sine function is an odd function, because it is odd, if I have cos and sine what? Sine minus s, I will get minus sin s. So this is odd, this is even. So we apply that here. That will give us cos beta s. The minus will be swallowed by the cos. But sine is an odd function, so the minus will jump out. So this plus become minus. So that is just the point. So you get minus high, then sine beta x. So this will be exponential beta s high. Okay, so if we substitute that into our y, now we have y exponential alpha x into a. So exponential beta s is giving us cos beta x plus I sin beta x, then b into bracket you have cos beta x again minus I sin beta x. So if you open bracket, you have a cos beta x plus ai sin beta x plus b cos beta x bi sin beta x. Now you could see that they are common terms. This one is common to this. If you put them together and factorize the cos, you get cos beta s in that fashion. And also for the sine, you get a high minus beta I, okay, then sine bx. Okay, now let's replace. So let d be equals to a plus b, and let e be equals to this part. Okay, if you do that, now y is equals to exponential alpha x into a into d now cos beta x plus e sin beta x. So this now we call it the general solution. So the point is, if you have a complex solution alpha plus beta I, this, so your general solution will just be this So the alpha you get will be here, then you get a constant cos, the beta will be here, you times it by s, then plus another constant, then sine beta x. So this E and D could be anything. You can even put A and B there. You can put C and F, any constant. Okay. So that is for that. So let's look at some examples. Okay. So say solve the differential equation. You have d2y dx squared minus 3dy ds plus 2y equals 0. Solution. So we need our auxiliary equation. So auxiliary equation becomes m squared minus 3m plus 2 equals 0. So this is m, solving this quadratic equation, this is m minus 1, and then m minus 2 equals 0. M minus 1 equals 0, which means m is equals to 1. And also we have m minus 2 equals 0, which means m is equals to 2. So you could see that 1 is not equals to 2, so they are distinct roots. So our general formula for distinct roots is given by a exponential m1s plus b exponential m2x. So this is, we can call this m1 and call this m2. So if you replace that, I don't want to do that on a single line. So if you replace that, you have m1 to be 1, so that would be 1x plus b exponential m2 is 2. So 1x is still the same thing as x, and that is same thing as 2x. So this is your answer. So moving on, let's do question 2. Solution. Auxiliary equation is m squared plus 6y plus 9 equals 0. Okay, so this is m. This will now give us m plus 3 times m plus 3 equals 0, which is same thing, yeah. So which is saying m is equals to 3, m is equals to minus 3 twice. So you could see that you have equal roots. So the general formula for equal roots is a plus bs. So that is how you use the formula ms. So your m now is that your ms is minus 3. So you put minus 3 here, and that will be all. So let's solve the last example under this. Okay, so if I have y prime prime minus 2y prime plus 10 equals 0. So if you do what times y the auxiliary equation, sorry, you get m squared minus 2m, this is y, plus 10 is equals 0. Now this times 10, this m squared times 10 will give you 10m squared. There is no 2 factor you will times that will give you that. If it gives you 10 and then you add it to give you minus 2, it is not possible like the other cases we've considered. So now you use your formula method, which is m is equals to minus b plus minus b squared minus 4ac over 2a. In this case, our a is 1, our b is minus 2, our c is 10. So insert it here, you get minus into minus 2 plus minus 2 squared minus 4 times 1 times 10 divided by 2 times 1. So that will give us 2 plus minus square root of 4. That is, you get 4 minus, this should give you 40. You divide it by 2. So at the end of the day, you get 2 plus minus 4 minus 40 is minus 36 divided by 2. So you could see whenever there is a minus under a root, that is complex already. So you get 6i divided by 2. So now you need to split the denominators like this. So if you split it, this become 1 plus 3 i's. Okay, now what is your m1? So your m1 is 1 plus 3i, while your m2 is 1 minus 3i. So these are like distinct roots. Okay, so this is complex though, so what you need is your alpha. I don't even need to write 1 and 2. So your alpha is 1, and then your beta is what? Is 3, coefficient of the complex number. So what is the general formula when you have a complex solution? This is it: cos beta x plus b sine beta x. Okay, this is what you need to remind yourself. So with this, what will y be? You have, sorry, I think there is an s here. So you now have exponential s is equals to a cos 3x plus b sine 3x. So that is all. Now, before we end this lecture, let's look at another important concept called the initial value problem. We call it the IVP problem. So when an initial condition is given, so the second order ODE becomes an initial value problem. So it means we should get a unique solution. So what we had before was a general solution. So if they give you an initial condition, it means you have to get a unique solution. So let's consider an example. If I have y prime prime minus 6y prime plus 25y equals 0, then I say y equals 0 is minus 3 and y prime of 0 is minus 1. So this is how the question will come. So this part that says y equals 0 is minus 3 and y prime is equals to minus 1 at 0 is what we call the initial conditions. Okay, so when they attach this initial condition, it just means you have to get a unique solution. But to get a unique solution, you need to get the general solution also. So let's consider the auxiliary equation. We get this plus 25 equals 0, and here too we have to use the formula method: b squared minus 4ac over 2a. Our a is 1, our b is minus 6, and our c is 25. Okay, so minus into minus 6 plus minus, get minus 6 squared minus 4 times 1 times 25, then we divide it by 2 times 1. So this gives us 6 plus minus square root of 36 minus 100. So we are dividing it by 2. That gives us square root of minus 64 divided by 2. So this will give you 8i divided by 2. You split that, so you get 6 over 2 plus 8i. This is 8i. So 8i divided by 2, that gives you 3 plus minus 4i. So alpha is 3, beta is 4. So moving on, let's put that into our formula. We have exponential 3x into a cos 4x plus b sine 4x. Okay, so that is the general solution. So we're given that y at 0 is minus 3 and y prime at 0 is minus 1. So how do you use this? So now we what it means is, for the first one, it means at s equals 0 your y is minus 3. So we put 3 minus 3, and then for x you put that 0, and then you also get cos 0 plus b sine 0. What is exponential 0? It is 1. Okay, cos 0 it is 1, y sine 0 is 0. So the only person that will survive this erosion is only a. So it means that a is equals to minus 3. Now let's use the other one. The other one say y prime. You need to find the derivative of this, so which we are going to use the product rule. So you keep 3x and then differentiate the content of the bracket. So that would be minus 4a cos 4x. Sorry, using the product, so you get minus 4a sine 4x plus 4b cos 4x. So this is how you differentiate. So this is for the first, it's product rule. So you say plus, you keep the bracket as found, and then you differentiate this. If you differentiate, I get 3 exponential 3x. So it says at s equals 0, y prime is equals 0. So you put 0, sorry, y prime is equals minus 1. Sorry. So you say minus 1. This becomes exponential 0 into minus 4a sine 0 plus 4b cos 0 plus a cos 0. Okay, this should be in bracket, plus b sine 0, then 3 exponential 0. So you see where everything lies. This gives us 1. So that gives you 4a sine 0 is 0. So here is 0 like that, plus 4b times 1 plus 3 can come. Okay, let me just open the bracket again. So this is a times 1, that b is 0, then 3, because exponential 0 is 1. So at the end this is 0. You only have 4b plus 3a. So we know that a is equals to minus 3. So what happened? You insert minus 3 there. So we have 4b minus 9. This is minus 1. So you have minus 1 plus 9 equals 4b. So that is 4b is equals to 8. So b is equals to 8 over 4, which is 2. At the end of the day, we have a is equals to minus 3, b is equal to 2. So the general solution, which was exponential alpha exponential, let's go back to our general solution. We have exponential 3x into a cos 4x plus b sine 4x, which is a general solution, will now be minus 3 cos 4x plus 2 sine 4x. So this will now be a unique, this is what we call the unique solution. Okay, thank you very much, see you in the next video.